Okay, in this section, we're going to start talking about conic sections. And a conic section, by definition, is formed by the intersection of a plane and a right circular cone. So you can see the cones down here. If you look at just the outside, imagine that cone is hollowed out. Just the outside, that is your conic section. The angle of the plane creates different types of these conic sections. Label each conic section below. So the first one we've dealt with in the past, the first one is called a circle. If you take that cone and you intersect it perpendicular to its height or parallel to its base, you're going to get a circle. Now, if you slant it just slightly, you're going to end up with an elongated circle called an ellipse. And you've heard of most of these. The next one you've seen as well. When you only intersect the side over here, you get a parabola. And the last one is your reciprocal, your y equals 1 over x, which we called a hyperbola. So all of these you've dealt with a little bit in the past, the equations of these. Okay, first off, circles. Now I want to start out with a non-transformed circle that we dealt with a little bit in the past. X squared plus y squared equals r squared. However, when you translate it, you move it, it's going to be an x minus h squared plus a y minus k squared equals r squared. Where that h and k is going to move it, the h is going to move it left and right, the k is going to move it up and down. To where the normal center over here was at 0, 0. But once you translate it, then h comma k is going to be the center and r would be the radius. So let's start out here. It says give the center and given the center and the radius, let's write the equation of this circle. So this center has been translated left 4, and to move it left 4, you simply do the plus 4 squared. Plus, we're going to move it up 6, so that's going to be a minus 6 there. And this is your r squared. Make sure you don't just put the 4, you put 4 to the second power, which is 16, and there's your circle. And if you were, again, to graph this circle, here's the center of that circle, and the radius would be 4. Number 2, let me zoom in a little bit. You have x minus h squared. Now, however, this one has not been moved. So therefore, you don't have to put a plus 0 or minus 0. You can just put the x squared plus. Now, this one has been moved down 2, so you're going to do a plus 2 to move it down 2. And since the radius is 7, this will be r squared, which is 49. Next one, we're going to move it right 1, which will be an x minus 1. Plus, we're going to move it down 5, which will be a y plus 5. And this will be the r squared. Now, to square a square root, reminder that you just have to take away the square root. So that would be equals 10. Next one, we move it right 9 by doing x minus 9. Plus, we're not going to move it up any, so you don't have to have a plus or minus. And then to square the 5 root 3, let me remind you, you're going to square the 5, which is 25. You're going to square the square root of 3, which is 3, and that would be a 75. So that's the equation of that circle. Now let's, given a graph, let's find some equations. So this one, let's see how far left or right we moved. Here's our 0, 0, 1, 2. We moved it left 3, so that'd be x plus 3. Then we moved it down 1, 2, 3, 4. So to move it down 4, you're going to do plus 4. Is equal to the radius is the distance from the center to the outside. This has a radius of 2, so that would equal 2 squared, which is 4. The next one, this one only has been moved. Here's the origin. It's only got moved up 1, so x has not been moved any, but y got moved up 1, so we're going to do a minus 1. The radius is the distance from the center to the outside. That's going to be 1, 2, 3, 4, 5, 6 boxes, so it's going to equal 6 squared, which is 36. Set number 3. What about if we're given a center and an endpoint? Now, we will have to remember the distance formula on this. Now, for distance formula, I like to use Pythagorean theorem. However, the actual distance formula, just in case you need it, is distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. You might also need the midpoint formula. To find the midpoint, and it is a point, you're going to take your two x values, you're going to add them, divide by 2. Again, you're averaging them. You're going to take your y values, you're going to add them and divide by 2. So you're going to average your x's, average your y's, because again, an average is the value that's in the middle. So to find the middle point, you are going to average those. So if we're given a center of a circle and an endpoint, that means we're given the middle and the endpoint. So the first part's easy. The center has gotten shifted left 2, so we're going to do x plus 2. Plus the center has got moved up 6, so that's going to be y minus 6. However, we don't have a radius. But we're given a center and an endpoint. A radius is the distance from the center to the endpoint. So now all we've got to do is find the distance from here to here. And again, the way I like to do it, and you can use the distance formula if you'd like, but I like to use Pythagorean theorem. I ask myself, how far is it from -2 to -4? Or what is my x change from here over to here? From -2 to -4, that's a change of 2. Then I say, what about from 6 to 12? What's my change there? And that's a change of 6. Then I simply do the Pythagorean theorem on those two values, and I get 4 plus 36, 40 is equal to c squared. So that distance on this problem is going to be the square root of 40. To get rid of the square, we square root. So therefore, my radius on this first problem is root 40. So therefore, my r squared will be just simply 40. I think Pythagorean theorem is so much easier to use than the other method. Number 8, and I'll use the distance formula here just in case you want to see it as with the distance formula as well. The center has been moved left 4, so that's going to be an x plus 4. It's been moved down 7, so that'll be a y plus 7 is equal to, we just need the radius. To find the radius, again, we can do distance is equal to, the radius is the distance from center to endpoint, so that'd be the square root of x2 minus x1 squared, so that'd be -1 minus -4 squared plus y2 minus y1, which would be a -5 minus -7 squared. Minuses change to pluses. That's going to be the square root of -1 plus 4, which is 3 squared, plus -5 plus 7 is 2 squared. That'd be the square root of 9 plus 4, which is 13. So my distance is the square root of 13. So therefore, since this is radius squared, that distance is the radius. So since this is r squared, it'd be plain 13. Now to have done that the other way, you would have done this. How far is it from -4 to -1? That's 3. Distance is always positive. You don't have to worry about negatives. How far is it from -7 to -5? That'd be 2. A squared plus b squared equals c squared. This is 9 plus 4, which is 13, is equal to c squared, so therefore c would be root 13. Same answer, much faster. Number 9, same thing, and I'm going to use I'm going to use my Pythagorean theorem. So my x value for my center has not gotten shifted at all, so we have plain x squared plus my y value got shifted up 4, so that'd be y minus 4 squared is equal to, I need a radius. The radius is the distance from the center to an endpoint. Again, I'm using Pythagorean theorem to find that. From 0 to 7, that's a distance of 7. From 4 to -2 on a number line, that's a distance of 6. Do the Pythagorean theorem, letting those two values be my legs, and I get 49 plus 36, which is 85, is equal to c squared. Do not worry about simplifying that, because you're about to take it and square it anyway. When you square a square root, it removes the radical, so you have equals 85. You can actually stop here because there's the value squared itself. That's what you're going to plug in. Next one, my center got shifted right 3, so that is x minus 3. Down 3, that's going to be y plus 3. And I need, again, a radius. Radius is the distance from the center to the outside. The distance from 3 to -4 is 7. The distance from -3 to 10 is 13. Now, that's some rather large numbers, but we're still just doing Pythagorean theorem. 49 plus 169 is equal to c squared. 49 and 169 is 218 is equal to c squared. So c will be root 218. But we got to square it anyway, so let's just put the 218 right there. Now, what if they give you the endpoints of diameter? Okay, the diameter is the distance all the way across a circle. So how are we going to find the center? Well, the center would be the middle of those 2 points, so we're going to use the midpoint formula to find the center, and then do the exact same thing we did on the last ones to find the radius. So therefore, first up, the midpoint. To find the midpoint, you add your x's and divide by 2. Then you add your y's and divide by 2. So therefore, the midpoint here is 2, 7. So we can go ahead and start our formula. We moved to the right 2, and we moved up 7, so it'd be minus 7. But we need a radius. To find the radius is the distance from the center, which we just found, to either outside point. I'm going to use this one just because then we're dealing with positives. So that radius, the distance from the center to the outside, find the distance between our x's, that's 3. Find the distance between our y's, that's 1, and do the Pythagorean theorem on those two values. We get 10 is equal to c squared, so c would be root 10, but we can just stop at the 10 and put that into our blank. And that's your equation. Next up, to find the center, this is the endpoints of the diameter. So to find the center of our circle, we're going to find our midpoint. To find our midpoint, we add our x's and divide by 2, and then we add our y's and divide by 2. That'd be a -4 and a 0. So our circle got moved left 4, that'd be an x plus 4. And our circle didn't get moved up or down any, so that leaves that at that. And we need a radius now. Again, the radius is the distance from the center to the outside. And you can use either point there. So therefore, the distance from 0 to -4 would be 4. The distance from -3 to 0 would be 3. And that's actually a Pythagorean triple. We know that our radius would be 5. Or you can actually perform a squared plus b squared equals c squared. 25 equals c squared. So c again would be 5. So therefore, my radius squared would be 25. Number 13. First off, this is the endpoints of the diameter. So we're going to find the midpoint to find the center of the circle. Add your x's, gives you -2 divided by 2. Add your y's, gives you 14 divided by 2. Our midpoint would be -1, 7. Therefore, our circle got moved left 1 by doing the +1. And our circle, to move it up 7, we'll have to do -7. So now we need the radius. The radius is the distance from here to either outside point. So the distance from 2 to -1 would be 3. The distance from 4 to 7 would also be 3. If you remember back in geometry, you could actually do, this would be a 45, 45, 90. So our hypotenuse here should be 3 root 2, if you remember that shortcut. Or again, you can do Pythagorean theorem, 9 plus 9, that's 18 equals c squared. So c would be root 18, which is that 3 root 2. But all we need is the 18 because that's our radius squared. Number 14, again, we need the midpoint to find the center of this circle. -16 and -14, add them, gives you -30. Add your y values is also -30. So our center is at -15, -15. So my equation is now x plus 15 squared and y plus 15 squared. And you can just take the opposite. Now to find our radius is the distance from the center to either outside point. It doesn't matter which one you use. From -15 to -16, the distance is 1. From -15 to -17, the distance is 2. So you have 1 squared plus 2 squared equals c squared. So 5 is equal to c squared. So c would be root 5, but we need the c squared. The radius squared would be 5, so therefore there's your equation.